When we configure IPv6 addresses on the Cisco routing interfaces, we can use the IPv6 EUI64 format. EUI stands for Extended Unique Identifier. Now, instead of entering the full IPv6 information manually, we can leverage on the MAC address of the interface to form up the host component of this IPv6 address. Now, the host component of this IPv6 address is 64 bits long, but the MAC address of the interface is only 48 bits long. So we include the extra bits FFFE in the middle 16 bits to extend the MAC address to 64 bits by inserting FFFE. So now we don't have to plan the host bits. The host information is automatically extracted from the MAC address of the interface. Now, on the leftmost, we have the universal or local bit identifier. Depending on whether the bit is set as 1, which represents a global address, and if the UL bit is set to 0, then this IPv6 EUI64 address is local IPv6 address. Now, when IPv4 was created many years ago, it's assumed that the host devices will be assigned this IPv4 address manually. But as our network becomes more and more complicated, it becomes a pain in the butt if the administrator has to manually assign IPv4 address to every host on the network. So Microsoft came up with this protocol called DHCP, Dynamic Host Configuration Protocol, whereby we are able to dynamically assign IP address to the host. Now, DHCP is not part of the IPv4 protocol. It is a add-on that was created by Microsoft. Now, when IPv6 protocol was being developed, it embraced the idea of allowing dynamic assigning of IPv6 address to hosts, as was done as the feature that was as in the feature of DHCP. So instead of done by DHCP, they would like to be able to dynamically assign IPv6 IP address to hosts themselves. So the solution that IPv6 protocol came up with is called stateless auto configuration, whereby when the IPv6 host boots up, it requests the prefix of the IPv6 address. Now, in IPv4 terms, think of it as the network address, and the router replies the IPv6 prefix of this LAN segment back to the host. Now, the host simply combines the received prefix with its own MAC address to come out with a unique IPv6 address for itself without requiring a DHCP server. Now, the stateless auto configuration is a nice idea, but one of the disadvantages of using stateless auto configuration for hosts is that the distributed way of doing things. because we never really know which host is getting what IP address, and we also cannot control whether unauthorized hosts are not supposed to get IP address. So what happens is every host will be assigned an IPv6 address, but at the end of the day it's very distributed, so everybody do their own thing, so you don't really have any centralized control. So that's why DHCP that's why DHCP, which was originally created for IPv4, is still being updated to support DHCP for IPv6, because even though IPv6 have this stateless auto configuration feature, it lacks the ability to provide centralized control like DHCP allows, whereby you have a centralized server or centralized device that controls who gets what IP address. Now, every segment eventually has a IPv6 address, but still the routers need to learn those IPv6 addresses from each other, and so we need to update our routing protocol to allow them to exchange and learn IPv6 addresses from each other. So there is the standard way of there is the more static way of assigning IPv6 routing information on the Cisco router, and many routing protocols such as RIP, OSPF, ISIS, BGP, and even EIGRP, they have been updated to support exchange of IPv6 routes between routers. Now, to enable this feature, you have to use this command IPv6 unicast-routing before you can turn on any of this dynamic IPv6 routing protocol, because by default the IPv6 routing process feature is disabled on the Cisco router. Now, RIP-NG stands for RIP Next Generation, okay, and is defined under RFC 2080. Now, RIP-NG is similar to IPv4 in the sense that there is still a hop count limit, okay, and they are still being governed, protected by split horizon, and they use concepts like poison reverse, okay, to avoid routing loops. And RIP Next Generation NG is based on RIP version 2. Now, some of the improvements to RIP-NG is that we do not use broadcast anymore. So instead, the communications between the RIP-NG routers are done through multicast addresses.